So we shall continue the discussion which we are continuing for last few sessions. Once the idea of Laplace transform application is clear to us, the methodology is very simple. Methodology is we presume zero initial conditions, therefore we can work with inductor and capacitor as good as resistor. Only thing which we say its impedance is for inductor Ls and for capacitor 1 upon Cs, and we can plainly analyze as resistive circuit. We take Laplace transform of input, we take Laplace transform of input, we analyze the circuit in Laplace domain, we find out VOS, that is the output in Laplace domain, and find out its inverse Laplace transform. So everybody, at least by the end of this week, I am sure that would be expert in getting the solution, even though what exactly happens in Laplace transformation, how exactly it is giving me the correct answer, that may not be known. But for any given problem, for any input condition, you must be able to get the answer by using Laplace transform. So in order to have variety of experiences, we will have some same circuits with different inputs or same input on different circuits. So just, I think whatever remains in our discussion in a particular lecture is supposed to be continued by you. So if something is unfinished on a particular day, then you are supposed to finish it on your own. And if some problem occurs there, then we are always open for discussion. So now we will have a small problem. Again, these are the problems which are to be solved only using chalk and blackboard or notebook and pen. Whether it would be actually implemented or not is a different question. Right now we are at a junior stage. So whatever input I am giving, such an input source cannot be realized. But still we must have, what we must have? We must have theoretical solution for all the things. Right? What is possible out of that and practically realized is completely different area of work. So at the initial stage, we should not at this stage, we should not worry about whether this can be put in practice or otherwise. Fine. I think the question is complete. Nothing remains in the question. So now there is no question of DC source and a switch. Whatever is V in T is of this form. Whether I would be able to give it, if I am able to give it, how I should give it, that is right now not our point of discussion. V in T which is being applied here is 0 till T equal to 0, and means it is of this nature. Right? It is 0 and then it's a 45 degree straight line. So you can find Laplace transform. You must be knowing Laplace transform of T. What is that? Laplace transform of T. Nice. So you find. So our idea is clear. VOS is equal to what? 1 upon S upon 1 upon S plus 1 into V in S. So find out V in S. Find out the Laplace complete HS into V in S. It's HS. have its inverse Laplace transform. Suppose till t equal to 0, right? So that no problem comes in our solution. So Laplace 1 upon s square, 1 upon s square. So what will happen here? VOS would be equal to VOS would be equal to what? Multiply by s, 1 upon s plus 1 into 1 upon s square. So what is the solution now? What is the solution? Where is the partial fraction expert? Where is he? Or what are the partial fractions now? It can be like this. A upon s plus 1 plus bs plus c upon s square, right? Is it like that? Or what? Then what?
B upon s plus c upon
B upon plus
is
same. Right? And c equal to a equal to 1, b equal to 1,
minus 1.
and c equal to 1. So invert is for this e raised to minus t, right? Plus b equal to 1 means what? 1 upon s. What does it mean? Minus 1. So minus 1, right? And for this plus is it like this? T plus e raised to minus t minus 1 or any ways. Is it right? Now we shall twist the problem in some different manner now. The circuit values are same. Circuit values are same. Determine what V in T will give me. Determine what V in T will give me the output as follows. You got the question? So input is not given now. To have the output to be VOT equal to T for T equal to 0 onwards, what input we require? Find out. First time. So now V in T is not given. We have to compute required V in T to have that VOT. Our basic theme is same. VOS is equal to HS into V in S. Right? Now VOS is known because VOT we want. So we have to find V in S. So V in S is equal to VOS upon HS. That's all. So Laplace transform of T we know 1 upon S square. So find out immediately.
LFT casting. 1 upon s. 1 upon s square. Any inverse of T. इन्वर्स काढल्या मला इकडे छाड पाहिजे ना L of T ते कुठनं काढला स्क्वेअर असं कसं आहे
So VOS at 1 upon S square is equal to 1 upon S plus 1 into V in S. Is it right? So V in S is equal to upon s plus 1 upon s square, that is equal to 1 upon s plus 1 upon s square, means we must have v in t is equal to 1 upon s means what? 1 plus is it alright? 1 plus t. Now we have to cross check in some manner. If v in t is, now what is the problem with us? We cannot find this solution because we are avoiding solution of differential equation. But if the solution is given, we can check whether the solution is correct or not, because we can write, there is no problem in preparing the differential equation, but there was some problem in finding solution. Therefore, now if you are asked whether v in t equal to 1 plus t, whether v in t equal to 1 plus t, whether this input will generate output which is VOT is equal to whether it will generate or not, that we have to check. Will it generate like this? How?
Yes.
How will you check?
Inverse of this answer.
So we have it. What is the basic differential equation? The basic differential equation is dVOT upon dt plus V0 is equal to is it right? Is it okay? How we have found out this? It seems that after we progress, we forget something. So how we have found this? We have found this. It is VOT, it is V in T. So what is IT? V in T minus VOT upon is IT. So IT is V in T minus VOT. Then since this is capacitor, IT must also be equal to, or then I can write same as in front of this only, dVOT upon dt. So this is the equation, and this VOT you can take on the other side. So dVOT by dt plus VOT is equal to V in T, right? Then now you just, for checking whether the answer is correct or not, what we do? We compute LHS, we compute RHS, and if both match, then our assumption is, or the solution found is correct. So dVOT by dt, what is VOT now? VOT is V in T is 1 plus T, VOT is T, right? So dVOT by dt is 1 plus T, and V in T is 1 plus T. Are you getting me? So that you, by knowing V in T, you might not be able to compute VOT, because it requires to solve this differential equation. But knowing VOT, you can find V in T. For that, there is no need of Laplace, because we can find differentiation, no problem. The problem of what we cannot find here, VOT we can't find because it comes in differential form. V means knowing V in T, finding VOT requires solution of differential equation. But knowing VOT, we can find V in T simply by differentiating. ux is this. So multiplying by s is 1 upon s square plus s plus 1 into 1 upon s square. Is it right? So it will have a, b, c, d. Is it okay? A, b, c and d. So you find out a, b, c, d and that's all. Okay, recording off.